Chapter 9 is called Functions in Algebra. In this chapter we will learn about 3 new types of functions: fractional functions, square root functions, and power functions. Besides that, we'll also learn the rules for calculating with square roots, powers, and fractions. We will start today with section 9.1, square root functions. A square root function is a function where the variable x is underneath a square root. This is the most simple square root function that you can think of. Fx equals the square root of x. Now we cannot just take any value of x that we like in a square root function, because we already know that we cannot take the square root of a negative number. That means that this function only has results when x is 0 or greater than 0. You can write that down like this: x is equal to or greater than 0. That means that the graph isn't an infinite line as well. It has a beginning point. This is the graph for the square root function I just mentioned, and it starts right here at the origin at 0.0. That's because the smallest number you can fill in for x is 0, because the smallest number you can take a square root of is 0. If you do fill in 0 for x, then the result will be 0, because the square root of 0 is 0. That means that the beginning point of this function is at 0.0, and that point is called the boundary point. Now in this section, the most important thing is to calculate the boundary point for different square root functions. Let's look at a few examples of square root functions from exercise 3, 4, and 5 and see if we can calculate their boundary points. Let's start with exercise 3. The first square root function that they give us here is the function f of 1 plus the square root of x. If we're looking for the boundary point, then we have to look for the smallest value for x that we could possibly fill in. Now in this case, it's the same as the example I mentioned before. The smallest number you can fill in is 0. If you do fill in 0 for x, then this square root part becomes 0 again, but then we also have to add 1 to that. So the result when we fill in 0 is 1. That means that the x-coordinate of the boundary point is 0, because that's the smallest number that we can fill in for x, and the y-coordinate of the boundary point is 1, because that's the result what we get when we fill in for x 0. Further in exercise 3, they give us function h. h of x is 2 times the square root of x, and we have to look for the boundary point. The smallest number I can fill in for x is again 0, so that's the x-coordinate of the boundary point. When I do fill in 0 for x, I get the calculation 2 times the square root of 0. The square root of 0 is 0, and 0 times 2 is 0. So the boundary point for function h is 0.0. In exercise 4, we get this function. F of x is the square root of x minus 3. Here, the smallest value that we can fill in for x is not 0, because if we fill in 0 for x, we would get the number minus 3 underneath the square root, and it's not possible to take the square root of the number minus 3. The smallest number that we can fill in for x is the number 3, because then we have 3 minus 3 underneath the square root, and that's 0. So the x-coordinate of the boundary point here is 3, because then the part underneath the square root becomes 0. If I fill in 3 for x, I get the calculation square root of 3 minus 3, which is the square root of 0, which is 0, so the y-coordinate is 0. In exercise 5, we get the function k. k of x equals 2 plus the square root of 3x minus 12. Now here it's not as easy to find out what value of x is the smallest value we can fill in. You might already see it, but if you don't, here's how to do it. You take the part of the function underneath the square root and you equalize it to 0. Now, we know how to solve this. We can use cards, for instance. We get 3x has to be 12, and then x is 4. So 4 is the smallest possible number we can fill in for x, so that the square root is taken of the number 0. So that means 4 is the x-coordinate of the boundary point. To find the y-coordinate of the boundary point, we have to fill in 4 for x. So we get 2 plus the square root of 2 times 4 minus 12. Well, 2 times 4 minus 12, that's 0. So we take the square root of 0. To that we add 2, and 0 plus 2 is 2. So this is the boundary point of the function. In the method on the bottom of page 55, this is explained again. These are the steps that you take. If we look at this example, function f is given, and we need to calculate the boundary point. What you do in the first step is make the expression underneath the square root signal equal to 0. So we get 2x plus 10 equals 0. Step 2 is solve that equation to get the x-coordinate of the boundary point. Well, this equation has solution x equals minus 5, so minus 5 is the x-coordinate of the boundary point. Step 3 is to fill in that found x-coordinate to calculate the y-coordinate of the boundary point. So if we fill in minus 5 for x, we get the calculation minus 4 plus the square root of 0, which is minus 4. So the boundary point of this specific function is minus 4 and minus 5.